and always review. You can always review at your convenience. I will share the recorded version with all of you in the Google Drive, and then you can repeat if or go to any section that you are not sure or not clear. Okay, I'll just go straight away to the topic today, in which we are going to look. Can you see this PDF slide? Someone, because I couldn't see the Google Meet interface.
Boleh tak?
Okay, good.
Ada.
Thank you. Okay, hope you've got a very good connection lah, internet connection, so to ensure a smooth class today. So okay, we come to the section in which for the generation of high voltage, and then I record the video, a lecture video for the generation of high voltage for AC and high voltage for DC. And now we come to a topic of where is it? Okay, high voltage impulse. Okay. What do you understand about the impulse voltage? Impulse voltage. Ni saya nak kena tanya ni kalau gitu. Avala. Since this the interactive class, right? So Vala, what do you understand about the impulse voltage? Sorry, Vala. Apa ni? PA Vala. Tak ada. Fatin Farhah lah. Fatin?
Ni doktor.
Apa yang what do you understand about the impulse voltage? Tak payah mute. What do you understand about impulse voltage?
Impulse voltage. Kalau tak silap saya, impulse voltage ni yang dia punya voltage dia tu tinggi, lepas tu hilang.
Okay, that is what you understand with the impulse. Alright.
Lightning strike.
Okay, lightning. Ni Nurul Fatihah.
Ya, doktor.
What do you understand about the impulse?
Lebih kurang macam Fatih Farhan. Dia unidirectional voltage yang sampai ke peak lepas tu turun macam tu.
Okay. Okay, peak turun. Don't you think that AC also will have a peak and then turun? So Clarice, how you to pronounce your names? Clarice. What is the difference? Because Nurul Fatihah mentioned, Fatihah and Fatin Farah mentioned that there'll be a spike that rise in the voltage and then coming back, and we have the same character for the AC. We have the peak, we have the rise in the voltage and then coming down. What is the difference between impulse to the AC? Claire? Boleh tak? Okay, Muhammad Adib lah. Adib.
Ya, doktor.
Dia
kalau dia punya signal tu kena rectangular.
Kena rectangular. Betul ke impulse macam tu? Itu square shape.
Kalau
shape punya waveforms.
Waveform dia rectangular.
Oh, itu yang you faham lah. Okay, for this one, impulse, in simplest mean, impulse adalah almost instantaneous ataupun a transient. Transient means the rise in the voltage level that happen in a very short period of time. Means that if we can have a smooth line or AC DC line, and then suddenly we'll have a spike. Okay, spike at very at the microsecond, at the nanosecond, the sudden rise in the magnitude and then sudden drop in the magnitude, then that is what we classify as impulse voltage. Mean that the sudden rise in the magnitude in term within a very short period of time. Okay, for if we have the sinusoidal waveforms, we might see a spike at the waveforms, or later I will just characterize. We can actually characterize the impulse voltage in terms of the wave shapes and waveforms. Okay, similarly to the AC and DC. DC we have a one straight line because the direct current, and then AC, for AC we have the sinusoidal waveforms, and for the impulse we have a certain characteristic that we're going to see later. Okay, how? Okay, in high voltage, why do we need impulse? I think I'll just proceed straight away without asking the questions. Otherwise, it'll be like we will end up this class with 2-3 hours. Just wait you to unmute, and I'm not sure whether you are there or you away. Okay, that's fine. But I'll just go straight to the lecture. Okay, for this one. Okay, why do we need the impulse voltage? Okay, we need AC. Why we need AC? Because we want to for the voltage, high voltage transmission, we want the electricity supply. The generator generate the high voltage AC. I mean generate the AC supply, and then step up transformer to the high voltage so that we can use at home, domestic for the end user. And for direct current, for DC, we normally use for testing. And we start to implement the AC, HVDC in some application, like a transmission as well, but very limited. And now we come to the impulse. What is the need for the impulse voltage in application in real life? Why do we need this one? Okay, the pure reason of why we keen to generate the impulse voltage is because we want to simulate. Okay, we want to simulate the lightning impulse, lightning strike, lightning waveforms, and we also want to simulate the switching waveforms. Okay, these are the waveforms that normally occurred in the daily life, in the environment, and in the applications. Okay, we perform switching. If we analogy to our domestic house, we will need to switch on and off the electric supply. For example, you will need to switch on and off the lighting, the light, the lamp, or the fan, or anything, equipment. Okay. Similarly to the transmission, distribution, substation, and etc., we also need to switch on and off the high voltage appliances, the equipments, so that we can proceed with a certain requirement. For example, service and maintenance, repair. That is the example for switching. And lightning, of course, this is the natural phenomena that we can't avoid. That's from God. Okay, so we at some point we need to simulate or study the lightning character so that we can design power system equipment and protection device, so that we can design all of this equipment that match or can sustain the lightning strike. That is why we need to generate the impulse waveforms in order for us to do some research, to do some studies on how we're going to prepare for the power system equipment. So it's pure. We don't use the impulse in many applications, except maybe on some application like a medical, like we inject a very high voltage at a very short period of time, for a certain reason. For a certain reason, for example, in medical. Other than that, we don't really use the impulse voltage or current. Mainly for in high voltage application, we use the impulse just for the research and for the testing purpose. Okay, we need to test the insulations. We need to test insulation coordination. We need to test the protection device and equipment that been used in the applications. That is why we need the impulse voltage generator. Okay. How to generate, how to actually produce the impulse. Okay, normally in many cases we need to use the device capacitor, resistor and the spark gap. Capacitor, resistor is a combinations. We rearrange the circuit that we will have a certain configuration by utilizing the capacitor as well as the resistor to develop the impulse voltage and the spark gap. I will explain later the use of the spark gap. Okay, the spark gap is very important. This is the one that trigger the impulse voltage. Okay, and we can generate a negative or positive polarity of lightning. Either is going downward or upward. We can set it. We can set the voltage magnitude. We can set the waveforms of the lightning by adjusting or by designing the capacitor and the resistor value. These are the two devices that will determine the waveforms, either it's negative or positive, the magnitude, the rise time, the decay time. These are the one that will determine our final waveform. Alright, there are two main categories as I explained earlier. One will be the lightning, one for switching. This, not traditional, we have other impulse waveforms, but these are the most commonly considered for the high voltage application. We want to consider lightning and switching for the reason that I just explained earlier. And the difference we have here, for example, to standard one, 1.2 /50 microsecond. Okay, these are the parameters that will determine the rise time and the decay time. And while for the switching, it is 250 and 2500 microsecond. So if you can see here very clearly, the rise and the rising and the decaying time is slightly different between these two values that determine the lightning strike is okay. Under this condition, if we are talking about the microsecond, means that we can actually refer it as a transient condition, TRANSIENT, transient conditions, because that is the occurrence at a very short period of time, or we can call it transient, we can call it impulse. Impulse voltage, impulse current, or transient voltage, transient current. Normally we refer it at transient time. Alright, so we will see the waveforms later. And okay, the magnitude of the impulse, of course, as I explained in the HVAC generator, we can generate for the higher magnitude level by cascading several single straight insulator to obtain the higher value voltage output. Okay, in this case, for the impulse, we going to see we can actually reach that level by using the number of stage. I will explain later what is referred as the stage circuit, right? But it is almost similar to the cascaded, right? Means that we cascade the several circuit to obtain the higher level value. All right, and then okay, these are among the common problem related to the impulse generator. Okay, as I explained in the HVAC, when we talk about the impulse or higher voltage equipment, these are typically very expensive. That's why we tend to use the cascaded version or the mux generator versions. And then since we are dealing with impulse, the test is dangerous. We need extra precaution for any testing related to the impulse voltage, because we are dealing with a very high magnitude, even though at a very short period of time. Because and another big issues related to the impulse generator at the laboratory is that for the AC/DC is kind of straightforward and quite easy for you to decide for the voltage level. Say means that if you set it the HVAC to be 10 10 volt, you can actually adjust the knob to be at the 10, as well as for DC. But for the impulse issues, for the impulse, the tendency, the magnitude level, the precision for the magnitude level is almost impossible to obtain 100% efficiencies. Means that if we set the impulse voltage to be at 100 kV, it's rarely for us to obtain 100 kV at the oscilloscope, at the output, at the test object. What will happen is that maybe it will varies. If you can see here, the efficiencies varies from 0.6 to 0.9. Means that if we want to generate the output voltage at 100 kV, we might end up with the output voltage only at 60 kV, or maybe 70 kV, or maybe at 90 kV, or maybe 95 kV, and even maybe 110, 120 overshoot. It is very difficult to obtain the value, the desired value. This is what is meant by the probability to be about 0.6 and 0.9. It can plus minus. It could be lower and it could be higher. If you set it to be 100 kilovolt output of impulse, you might end up with 60, maybe 50, or maybe 150, or maybe 120. It depends. Because the impulse waveform is actually something similar to the lightning. It is uncertain due to arrangement of the circuit and the charging and discharging of the capacitor, right? So it's very hard. Through my experience as well, it's very impossible to obtain what we want. What is the desired value? And another things, when we are dealing with high voltage, obviously we need a relatively bigger clearance or large clearance area. Large clearance area means that the higher the magnitude, the larger the test area is required in the laboratory. So more space is required. If the clearance is very small, for example, we want to generate 100 kV and our room is very small. When you place the impulse generator at the middle of the room, and in fact, the distance, the clearance, the distance to any other structure, nearby structure is very minimal, and then we might end up with the impulse or for a condition that is termed as the faulty conditions, in which the generated output will just flash over to the other nearby structure. So we need to make sure the insulation coordination also need to be good, and the required space or clearance from the testing object is also need to be as per standard. Okay, similar to the HVAC, as I mentioned, we also have the single circuit and we have the cascaded circuit or multiple stage circuit. This is the cascaded version of HV impulse. Okay, so we have the single and we have multiple circuit, in which normally we call it as the Mach generator. Why Mach generator? Because this is actually the name of the scientist who initially proposed for this kind of circuit arrangement. We call it Mach generator in order to produce a relatively higher impulse values. Okay, for the single stage impulse generator, obviously a single stage, we are dealing with relatively low impulse voltage level, and this is the one that we have in the high voltage lab UTHM as well, and it capable to produce lightning impulse at 500 kV peak. Okay, peak. So means that this is single stage impulse generator. How are we going to obtain the 1,000 or 1 mega, 2 mega? The only way for us to obtain that value is by using the multi-stage impulse generator or cascaded version of the transformer. Alright, so then only we can achieve that. Why? The reason, as I explained previously in the recorded video, is that we are dealing with the if we go for the higher output voltage capacity for each equipment, we will end up with the spike for the cost, and as well as for the maintenance as well. And not only that, the cost is rise exponentially, and then we need to also consider about the insulation coordinations, the space, or the safety clearance, the clearance distance from the test object and nearby structure, many other important things that need to be considered. Okay, and in order to generate the impulse, okay, because as I mentioned, we have two important equipments or device related to the impulse, is that capacitor and the resistor. Okay, why we need this equipment? The capacitor is mainly for the charging and discharging. Charging and discharging of the capacitor in order for us to establish with the required waveform. Okay, this is the equivalent circuit. Okay, we have two circuit. Charging circuit, we call it wavefront. Okay, and discharging circuit. And discharging circuit, we call it as wavetail. What is wavefront and wavetail? This is actually the waveforms. Okay, the waveforms of the impulse, and we can see the wavefront is actually the waveforms from the zero going to the peak, and the wavetail is actually from the peak decaying down to zero. Okay, that is during the discharge, and then for the going up is we call it charging. Okay, it needs to be a combination of these two, then only we can establish the impulse waveform. Charging only will not will only generate an increasing, and then if you don't have the discharge, and then there will be no for the decaying time, or they will no decaying in terms of the output waveforms, and hence we couldn't call them as a impulse. Okay, this the equivalent circuit, and this circuit is actually the combination of this 1 and 2. Okay, so we combine them together, and then we will have this circuit. so that to establish the impulse waveform. We need to combine them, otherwise the waveform will be different. Okay, so if we look carefully here, we have the capacitor and resistor, but here we can't one capacitor here is the stage capacitor, right? Stage capacitor is for the charging capacitor. Okay, and then we have the tail resistor in parallel to the capacitor. We call it tail because this is the one, okay, the voltage flow through this resistor that will actually produce the tail waveform. Okay, and then we have the front capacitor here in parallel to this, and this one in parallel to the test object, and we also have the front resistance. Okay, so there are two resistor and two capacitor, two resistor and two capacitor, and this is another important element for the impulse. Without the trigger gap, okay, this is TG, trigger gaps. Without the trigger gap, we definitely cannot develop or establish the impulse waveform. Okay, okay, why we need the trigger gap? Okay, trigger gap, the function is that once we apply the voltage, we supply voltage to the capacitor charging. Okay, once the capacitor is charged to its full level, or maybe half level, okay, we need to, the trigger gap is required to short circuit, okay, to short circuit and allow the conduction. Okay, we charge this capacitor to a certain value and discharge this capacitor by using the trigger gap to short circuit this circuit, to short circuit to allow for the current conduction. How we trigger the trigger gap? How we short circuit this equivalent circuit? Actually, normally, there will be two options for the trigger. One is by external source or external source from other circuit, and the other one is actually the breakdown, the air breakdown between these two spheres. Okay, how and why or at what level we going to decide whether to use the external or to go for the external circuit? Okay, the external circuit, the function of the external circuit that will trigger the spark between this one, the external will trigger this one, and then hence this will be conduction within the this circuit. Okay, say we want to produce the output, the impulse output at the 100 kV. Okay, and the charging capacitor here, the stage capacitor or the charging capacitor here, if we charge fully, and it could, maybe I would say, let just put an example that this can actually charge and produce up to 200 kV. Okay, and then there will be a certain clearance distance between these two, that presetting, okay, that presetting in case we want this capacitor to discharge at 100 kV. So the trigger gap need to be adjust to a certain distance, make them closer, so that at the very high stress level there will be a discharge between these two. The breakdown, the air breakdown, so that the circuit will conduct and trigger the impulse. That is the reason why it is, as I explained before, it is very difficult to obtain the 100% accuracy because of these issues. The trigger gap, we never know when the discharge, the gas will break down between these two electrodes. Sometimes it will break down at the, at the much lower voltage level, and then sometimes it would require a higher voltage level depending on the ionization process within the gas. So the trigger factor, the magnitude of the output is totally depends on the trigger gap as well. At which level in what this one want to trigger. That's why sometimes it is much easier for us to go for external circuit so that we can trigger manually. Once we charge the charging capacitor at the desired value, for example, we want to generate output 50 kV, we charge the capacitor to a 50 kV, and then once we reach this 50 kV, we push the trigger button, and hence the external spark will be established between here. Then there will be a current flow. So hopefully by using the external, this one will be far effective compared to the breakdown, air breakdown between this one, manual air breakdown without the external. Okay, that is how we generate and trigger the spark. Okay, first we charge. Okay, there will be some time. Okay, the charging time is depend on the capacitor as well, and the output. The voltage supply. Sometimes we charge up to 50, might take maybe 1 minute, 3 minutes. Sometimes with the higher capacity of the equipment, sometimes 50 kV we charge only in half a minute. It depends. Okay. And then this is the charging, and then once it reach to the breakdown value, it will break down and then it will conduct. Okay. Now how the waveforms is established? How the waveform is generated? Okay, first we have this what we call it as wave tail circuit, and then this is what we call wave front circuit. Why this one is called wave tail, and why the other one is we call it as wave front? Okay. The one kalau kita tengok, if you look at from this side, we should call this one wave front, right? This is tail. But that's happened otherwise, in which we have the wave tail circuit at the front and wave front circuit at the back. I would say back, because from left we will see this one first, then only this one. But we call it this one wave front. Why? Because actually this circuit is actually produce the wave front waveform. The wave, let me just, okay, this one. Okay, the circuit is actually generate the one that is shown here, from the 0 to the peak values, and for the tail, that is the circuit actually responsible for this shape. Okay, wave front is by the circuit, and wave tail is by wave front for this waveform rising up, and for the decaying is from the wave tail. Then only we by combining the waveform all together in one circuit, we have rising up and decaying. If we apply only one circuit, it will only rising up. Okay, and if we applying another circuit, it will only decaying. Okay, this is charging, this is discharge. We charge to a certain value, and then discharge is going down to 0. Okay, so here we have the charging capacitor, trigger gap, and the RT. Okay, RT. Okay, RT is the tail resistant. Okay, we call it tail resistant because the voltage drop across this resistor is the one that is responsible for this one. Okay, for rising up during the charging. Very good. Okay. Sorry, tail. Tail is decaying. Decaying. Decay. What happened? Okay. Okay, and this one is responsible for the rising. Okay, once we charge this stage capacitor, the front capacitor will also be charged. This one will consider is going up, okay, because they are in parallel. It will also rise up, and then let's just okay the connection. Okay, if okay, as I explained, effectively from these two circuit. Okay, the stage capacitor CS is initially charged to the predetermined HVDC, as I explained before. First, we set the aim value, say 100 kV. We charge the capacitor to 100 kV, and then we will discharge through this trigger gap. And the trigger gap, okay, once the trigger gap is closed, means that the short circuit, immediately the capacitor across, okay, the capacitor voltage across the tail resistance, then gradually will start to reduce its magnitude. Okay, once we trigger this one, the voltage across this one will reduce. Once we trigger the short circuit this one by the trigger gap, the voltage across this RT will reduce. That is why it contribute to the decaying of the insulator. The tail waveform is created. Okay, upon the conduction, okay, that is one. Okay, upon the conduction of the wave tail circuit, okay, wave tail circuit, this one. Once we trigger the trigger gap, and then there will be a conduction. Okay, okay, the conduction within this material, and then the voltage across. Okay, the voltage across RT, okay, this voltage across the RT, of course, once we trigger this one and it becomes short circuit, and there'll be a conduction, and there'll be a voltage drop across this one. Once we have this one, and then this will contribute to the charging of the CF, the front capacitor. Okay. This one will drop and this one will be charging. That is the reason this one showing the decaying of the waveforms, and this one is showing the rising of the waveform. We are talking about a microsecond. Microsecond. We are talking about microseconds, means that this happened very fast, very quick. So this one once trigger, this one discharge, and this one is charging. This capacitor will be charging. And the CF normally a voltage divider. This is the voltage divider that we introduce to control the voltage at the output, at the test object. Okay. And the time constant for the CF and RF, okay, front resistor or front capacitor will be much lower than the stage capacitor and the tail resistor. The time constant is much lower. That is the single stage circuit. Okay, this is the single stage circuit in which how we going to produce 100 kV or 100 kV. Okay, and these are the waveforms. Okay, we have the switching, we have the lightning, and to differentiate between these two is actually by this character, the time, specified time here. The 250 is the rising time, means that the time to reach peak, 250, and 2500. Okay, the 2500 microsecond is from the peak to the 50% of the peak values. Okay, not to zero. Okay, not to the zero, but it just 50 second. Sorry, 50% of the magnitude value. Say this one is 100 kV, the peak, and then the 50% will be 50 kV. So we count from the time to reach peak to the decay to reach 50 kV. So this is normally in this range, 2500. So as compared to the lightning, there will be 1.2 and the other one will be 50 microsecond. The lightning is faster, or the transient period is quicker, because we are dealing about 100 times. Switching is 100 times double of the for the lightning. Okay, we would expect maybe for all of you to be able to sketch this simple lightning or switching waveforms. If you can see, this is slightly in terms of the shapes, it is acceptable to make like this one. What most important is this parameter, and its bonus if you could draw exactly like this one, and if you can realize the shape is slightly different, but in general they are identical, except for the value of the rising and decaying time to the 50% of the magnitude. Okay, waveform that having a peak value of 150. So we have to decide. We have to be able to draw. Okay, now we come to the Mach generator, in which multi-stage impulse generator. Okay, as I explained briefly before, we need the multiple stage impulse generator because of we don't want to spend more on the high impulse generator on the single unit. Okay, and it is difficult to supply HVDC to a very high value. Okay, very high value. What happened with the multiple impulse generator is that, okay, we charge this 1, 2, 3, 4 and so on in parallel. Means that we don't really require a high voltage level, HVDC level to charge all the circuit. Okay, means that we charge them in parallel and then we discharge them in series. That's why we would just require a very relatively lower HVDC, but yet able to produce a very high magnitude at the output. Okay, so why we go for the multiple stage impulse generator? Because we don't want to spend money on to have the higher voltage rating for a single impulse. And then as I mentioned previously, we got the problem with to increasing the size of the lab. For example, the clearance, and as well as for the equipment, HV capacitor, we need to use a very big one, and a very big rating in order to develop for the very high magnitude. As for these two reasons and some other reasons, that's why we go for other approach by cascading. Cascading this one, the impulse generator, to obtain the higher voltage level. This is what we call Mach generator or multiple stage impulse generator. Okay, this is the one that I mentioned to you, charge in parallel and discharge in series. Okay, these are the circuit. Okay, this is 4-stage Mach generator, equivalent circuit. Okay, we have circuit 1, 2, 3, and 4. Okay, 1, 2, 3, and 4, just like the cascading transformer. Okay, we combine the circuit, and then this circuit will be charged in parallel. Okay, charge parallel, and then hence we just need the voltage source, relatively low voltage source, and then we discharge in series. That will be a combination of 1, 2, 3, 4, and then we'll get 4 times of the output voltage of one single generator. Okay, and we have during charging, and we have during discharging, the configuration, or circuit representation to describe the charging and discharging. Okay, let's move on. Okay, we have this is equivalent circuit. Okay, what is this? This is also equivalent circuit. Okay, this one equivalent circuit, this one is also equivalent circuit. It just the metal. This one rearranged so that is more convenience, so that we can really connect, make the connections to obtain the mark generator. Okay, we have okay, 1, 2, 3, and 4. Okay, this is 1. This is a single, kan? This is single, 1, 2, 3, 4. Okay, what will happen? We charge this one. Okay, let just see the explanations here. Okay, for the connection, okay, this is 4-stage mark generator. Then we have 4-stage capacitor. We have 4 charging resistor. So we have the 4 tail resistor, and then we have 4 sphere gap. Okay, if we want to generate 5 or maybe 6 stage mark generator, we need to have all of this equipment 6. Okay, it's just a duplicate or cascaded. Okay, and RD is, in this case, we have the RD is damping capacitor. Damping resistor, and okay, this is the RD. Okay, sorry, this one. Damping resistor RD 1, 2, 3, 4. Okay, we have the RD, and since the value of this RD is relatively smaller, so we can consider as a negligible. Damping resistor ni is used for a better waveforms. We are talking about maybe about less than 100 ohms, 40 to 100 ohms. While for the R1, R-tail, we are talking about hundreds ohm, or maybe 500 to 1,000 ohms. Okay, that is the difference. Okay. Okay, now how we going to supply the voltage to this impulse generator? Okay, for impulse generator, we use DC voltage. Okay, how to establish the DC voltage is by using the rectifier circuit, the one that we've learned in the HVDC. We have the AC supply, and then we step up the transformer, and then we have the rectifier, diode, etc. to obtain the DC voltage. Okay, this voltage is the one that been used as the input for the charging capacitor, stage capacitor. We can call it as a charging capacitor. We can also call it as a stage capacitor. All right. Okay, we have 4 in parallel. Okay, if you can see. Okay, if we have the voltage supply DC here. Okay, and we have the charging capacitor, stage capacitor in parallel. This is why the capacitor being charged. Okay, the voltage at point A, B, C, and D is actually identical because the voltage are in parallel. Okay, in this circuit configuration, we can really see that these capacitors are in parallel. And then, this charging resistor. Okay, we have the charging resistor. Okay, to the high value charging resistor as well as to the tail resistor. Okay, we have the stage capacitor, and this one, the voltage VC, voltage charging, VC, voltage charging. This one will pass through the RC and RT. What is RC and RT? This is not clear. Yeah. Okay, this one is RC, and this one is RT. RT at the bottom, RC at the top for this configuration. RT, RC. Okay. This is not another version of circuit. It's just the simplified version. This one is the simplified version for this one. Okay. In this arrangement, why we call it as a simplified, we may not see accurately for the connection, and we don't really see they are connected in parallel. In this way, we can really see they are connected in parallel. And during the discharge, we can really see they are connected in series. That is the advantage of this representations. Right, connection. Okay, sorry, where is it? PDC. Okay, the charging capacitor as the okay, they are act in the similar way of the tail resistor. The charging capacitor here, the tail resistor is here. They act in the same way when the generator discharge. Okay, when generator are discharged, but are usually high enough of value allow the tail resistor to dominate. Okay. RC and RT, they just act the same, but since the value, okay, the value is high enough so that the tail resistor is dominate. Okay, the tail because of the value, since the tail resistor is far away from the far higher than the RC, then the waveforms at this value will establish. Okay, and hence we can actually see the output voltage at across this one. Okay, after certain period of time, okay, A, B, C, D, at this point, we apply the voltage VC with respect to G, H, I, J, K. Okay, and this point is connected to the ground. This point is connected to the ground. We have this one charging capacitor 100 kV, and we have this one 0. That's why 0 volt, 0 volt, 0 volt, because they are connected to the ground, so that we have the potential different 100 kV on each stage. Stage 1, 2, 3, 4, and so on. Okay. And then okay, the load capacitance, CF at the test object remain at the 0, because this is on during the charging, and these are 0, these are high value. This is the moment before we trigger the spear gap here. Okay, how we trigger this spear gap? Actually, we trigger it by external, or it can be by manual, as by the breakdown between the electrode. In many cases, we just use external because this trigger gap need to be discharged in at the same time. Okay, in order for us to have the magnitude to the desired magnitude level, we need to discharge this circuit at the same time. Okay, 1, 2, 3, 4, all of these trigger gap need to be triggered at the same time. Okay, this is again the problem in which I explained before. Is very hard, very rare to obtain the desired value. If you want 100 kV, and in this case, if you want the 400 kV, okay, we generate 100, 100, 100, 100. So we expect to have 400 kV because we have 4 stages. Okay, we have 4 circuits here. And the problem is that once we trigger this one, they may not trigger at the same time due to various conditions, including the environment. For example, in the text, ambient conditions, and we might have the disturbance, small particle within any of these. This one will trigger faster than this. This one is slower. We have various factors that will contribute this trigger gap not to trigger at the same time, and hence what will happen is that the total voltage level at particular value will be far lower than desired value. So it means that once we expect the voltage to be 400 kV, we might turn up with the voltage about 350 kV because they are not discharged at the same time. It's very hard to control. Even we trigger, put the trigger, the spark trigger. This trigger may one spark spear gap 1 may trigger maybe 10 millisecond faster than the other one. This kind of uncertainties. Okay, and for this reason as well, for anything any testing related to the impulse generator would require testing number of testing for more than 20 times. For more than 20 times to obtain the average value. Okay, means that we inject voltage, we charge the capacitor and then inject, discharge, pump, okay, then generate. For example, 400 kV, 300 kV, and then the other one 350, the other one 370, the other 410. We will have these uncertainties for throughout the test. That's why we need at least 20 values to get the average value for this arrangement. Okay. Okay, the spear gap, the spark gap. We can say spark gap or spear gap, or trigger gap. We have G1, 2, 3, and so on. They need to spark simultaneously, as I mentioned, at the same time. And the discharge generator by additional impulse, impulse voltage, the sparking voltage. This is what I mentioned earlier. It can be triggered by the external circuit. It's just an external circuit. We trigger by a button, and then it will produce the sparking voltage to short circuit this arrangement. Okay, since the spear gap are normally set to just hold off the discharge, the presence of additional spark will cause the first gap G1 to break down. That is what I just mentioned. Okay, when this occurred? Second last slide. Okay, just bear with me. Second last slide here. When this occurred, sorry. Okay. When the discharge occurred, what will happen? Okay. What will happen when this occurred? The potential at the base of the second stage is changed from 0 to VC. Alright. This one, okay. Once we have the spear gap, once we trigger the spear gap here, there'll be a conduction. Current flow will come to this one, and immediately the zero voltage will become the VC. That is what is mentioned here. The voltage here will come through this one because we short circuit, and then immediately at the point H here, the voltage will become VC because we have the conduction, and the potential is now the same. Due to stray effect of the second gap. G1 still a potential at the tail, but the voltage at this level, at the RT, where is the RT? This one. At this RT, the voltage of 2 VC across it causing an immediate breakdown. Means that if we use the external circuit, the trigger gap will trigger this one, and hence we have this one almost 2 times of the VC, 2 VC, the voltage across RT, and this will trigger it to another stage to break down. We have, because the voltage is higher now, and then since this one is charged at a certain value, they are just waiting to be discharged. And with this high magnetic value, this one will also be triggered. And then the same happen to the next one, and so on. Okay, this situation continues across all the way of the top generator, in which spark 3 break down, and then will spark 4 and so on. So along the way, this one spark, this one 2, the value at this point will be 2 VC. Okay, then this one spark, this one will give 3 VC. This one spark will be 4 VC and so on. So we have these values. And then this will lead to the breakdown of all stage, in which will lead to the final waveform of either switching or lightning waveform. That will give us this kind of waveform, but at a different magnitude value. If we are using a single, not the mark generator, not the stage 1, maybe we'll just produce at this level 100 kV. But in this case, we are using 4-stage impulse generator in which each stage able to generate 100 kV. So we might end up with 400 kV impulse generator. Okay. So that is the arrangement of this equipment for charging and discharging of this multiple stage impulse generator. Right. And we have the test object here. Okay. If we can see, initially the voltage is 0 and this one is VC. Once we trigger this one will become 1 VC, and then this one 2, this one 3, and this one 4. 4 VC, okay, 4 VC to the test object. What is 4 VC? 4 times 100. 4 times 100 charging capacitor. Okay. So this one 100, this one 200, this one 300, this one 400. They are in series. Okay. 100 plus 1 plus 1 plus 1, and then that will give us 400 at the output to the test object. And that's why if we apply the test object at this point, we will have 300 kV impulse. If we apply at this point test object, we will have 200 kV impulse to the test object. Okay, I hope this very clear to everyone. And a quick one about damping resistor. Okay, the damping resistor, as I mentioned, it is to control the oscillation in the voltage waveform, in which we want the waveform to be in the nice waveforms. We don't want the noise and oscillation within the waveforms. That's why we use the damping resistor. Okay, as I mentioned, damping resistor is 40 ohms, and in comparison to the other one is RT is 500, 700, and the value is far lower than the RT. This is the use of the damping resistor. All right. Okay, I think that's come to the end of this session for the introduction on the impulse generator. And I explained to you the need or the importance of impulse waveforms, why we need the impulse waveform, and how to generate or how to develop the impulse for this one. And that is the end for the topic of the high voltage impulse generator. All right, with that, anyone, do you want to ask anything about this one or maybe the previous chapters? I'll just off record this one. Or maybe I'll just leave it. Okay. Farid Haikal. Farid.
Ya saya Doktor.
Ada soalan Farid?
Tak ada Doktor.
Kalau tak ada, saya nak tanya. I'll ask you. Boleh?
InsyaAllah boleh jawab.
Oh lah, muak hebat lah. Steady lah Farid. Betul 3 komponen utama dalam impulse generator punya circuit.
Komponen utama.
3 komponen utama. Macam mana kita nak generate impulse generator tu? Pakai apa? Equipment apa? Device apa? Tiga utama yang wajib. Mandatory equipment. Satu, capacitor. Dua,
Switching. Bukan
resistor.
Resistor.
Ketiga adalah trigger gap. Okay. Kalau tak ada trigger gap, if we don't have, we don't install the trigger gap, definitely we will not achieve the impulse. Okay. We need this three equipment, these three device in order to generate. Of course, we have the stage capacitor, charging capacitor, the front resistor, the tail resistor. These are the one that determine the waveform characteristic. If we want the characteristic to be slightly different, we need to change the value of the resistor and the capacitor. There are calculation to calculate or the magnitude and the waveform, and we don't include for this level. It's just for you to know that this value is actually contribute to the impulse waveform. Lagi Syazani ada? Syazani, Muhammad Syazani.
Oh, ada.
Ada. Makan aja ni.
Puasa dia.
Okay, Syazani ada soalan tak? Do you have any questions? Kat mana yang blur-blur? Anything that you need further explanation? Baik awak tanya. Kalau tak saya tanya awak. Ke dah faham? Dah faham
Sekejap tu.
Li Wen Yi ada tak? You have any question, Li? Li Wen Yi? Anything to ask, or maybe you want to leave it later? You want to study first?
So far so good.
So far so good. That's great. Syazani ada. Tengok you belik note saya akan. Okay. It's okay. It's just explanation. I hope you can revise the notes, read, and please don't just rely on the lecture notes. Okay? Please don't just rely on the lecture notes. I would encourage all students to find or to do their own reading, additional readings about the switching, about the impulse, about all of this what we discussed in the class for better understanding. Because obviously I can't explain so many things in a very limited period of times, and then you can make your own reading, own study, independent study to enhance your knowledge or understanding on this aspect. Okay, if you've got no questions, I think we okay. Before that, do you have any questions on the assignment or project? Anything you want to ask? Anything you want to ask? Siapa? Syahira lah, Nur Syahira. Nur Syahira, your group okay?
Okay, doktor.
Dah hampir siap dah?
In progress.
In progress, berapa persen?
Dalam 50%.
Oh, 50% What is the challenge for you to complete the project or assignment? The hardest part?
To design the to design.
Design apa? Insulator?
Yep.
Bukan mudah je ke? I think that's easy because we have the design, we already have the insulators available. You can use the catalog. It's just for you. We don't want something fancy. It's just for you to understand what are the specification for what value. Tak apalah, you can make your own readings. Okay, lagi Syaira, okay so far so good for the project and the notes.
Yes, Doctor.
P Valamate. PA, how to pronounce your name? Valamate. I called you early on, but you didn't reply. Ada tak? Tak Aci ni, tengah sarapan ni. Okay, who else? Nadir, Muhammad Nadir, your group semua okay?
Setakat ni okey.
Progress berapa persen?
Adalah 40% kot.
40. Awak sangkut dekat mana? Your group sangkut dekat mana? Which part yang sangkut? Ke cantik, kenapa belum 80%? Nadir?
Ya Doktor.
Kenapa belum 80%? Ada apa Nadir? Awak buat kat mana? Aku tak tengok lagi ni, your group. Siapa group member awak Nadir?
Dah tengok.
Dah tengok dah?
Grup saya Zukri, lepas tu Fatihah, lepas tu Muhammad Azim.
Semua group member okay Kamcing? Boleh go on
Boleh.
Okay, good. Tak apalah, saya I think I'll just stop here since you all pun tak berminat untuk tanya soalan. I would assume maybe you all dah fully understood or maybe not yet. You need your own reading first to further understand, then only you will ask something. That is fine. We reserve it in the next meeting, next week class. And then for next class will be at this time. And any update or change, I will let you know. Hopefully, the next class will be just on the Q&A, not more than that. Because to be honest with you, I already complete all the chapters with the student with my section, which is the introduction of high voltage. Number 2, the breakdown in the gases, gases, liquid and solid dielectric material, and the last one for my topic will be the high voltage generator. How to generate high voltage. With Dr. Fairuz, you will go for another section after generate for the testing, insulation coordination, and etc. Alright, okay. I think I will just stop here. Okay, before we dismiss, any last one? Anyone? Okay, if no, I think we sudahi with the tasbih kifarah dan suratul as para muslim. Subhanakallahumma bihamdika asyhadu an la ilaha illa